Welcome back. In this lecture, we're going to take a look at Xcode and iOS, and this is going to be a very high-level overview just to give you a sneak preview of the tools that we'll be using, as well as the overall software architecture or the approach that we use when we craft iOS native applications. So we'll look at the tools, and what we're talking about here is Xcode, which hopefully by now you've downloaded and installed a free copy from the Mac App Store on your Macintosh computer. And then we're going to look very, very briefly at Model View Controller, the architecture of iOS applications. So Xcode is the IDE that Apple has made available for developers who are interested in writing native applications for both their desktop operating system, so OS X, as well as iOS, the operating system running on iPhones, iPads, and now the Apple Watch. So as I just mentioned, it's available as a free download on the Apple Mac Store, but it does require you to have an Apple Mac computer. So you'll need a MacBook or a iMac, or the least expensive would be a Mac Mini. Now Xcode is a very typical IDE. It's a decent environment to code in. It has a number of features very similar to other IDEs, so maybe you've used Eclipse or other types of tools. There is integration with Git. Git is distributed version control system. The integration is okay, but if you're already a Git user and you're used to using the command line, you'll probably find yourself continuing to use the command line versus the Xcode integration. There's auto-completion and syntax highlighting, code folding, the types of things you'd expect in a modern IDE. There is a debugger that's fully integrated with Xcode. There's a GUI tool called Interface Builder, which makes it easy to create the UIs, the user interfaces for our applications. And nowadays in Xcode, there is support for deploying your application to the App Store. So when you're all finished developing and testing your application, you can actually archive it and submit it to Apple for approval for distribution via Xcode. That used to be separate tools, but nowadays that's all built right into Xcode. So here's a screenshot of the Xcode environment brought up on my computer, and you'll see the main part of the screen in the middle is the editor. So either we're editing Objective-C or Swift code, and if we were editing a storyboard or a nib file, which are the files that Interface Builder, so in other words, if we're designing a user interface, then the content of this editor would literally be the screen designs that we're working on. Over on the left side of the screen, you'll have the nav area, and here we can browse the project based on the files that are in it. We can also look at the project in terms of the software structure, so according to the class hierarchy. There's other tabs in this area as well. We can look at our breakpoints. There's an area for debugging, compiler errors, etc., etc. On the very top of the screen, we have our toolbar, and here we have tools to allow us to not only run the application or stop a running application, but we can also select the target that we want to run on, either a physical device that we've connected via our cable, or we can have simulated devices. So Xcode includes emulators. So we can, if we don't have a physical iPhone or an iPad, we can still test and run our application. And then over on the far right, there's some buttons on the toolbar that let us control how we're configuring or arranging these various windows within the IDE itself. Underneath the toolbar on the far right, we have the utility area, and what gets displayed here, it's really dependent on the context. So whatever we've got displayed over in the editor determines what we're going to see in the utility area. And as we start writing apps, we'll demonstrate the things that are available there. Underneath the utility area, we have the library pane, and this is particularly useful when we're an interface builder and we want to grab stock controls and use them in our user interfaces, but also for writing code. There's a tab, there's some code templates down there too that make it easier to do certain things. Then in the lower middle of the screen, we have the debug area. There's a couple of different screens there. We'll look at that in more detail, but the debugger is integrated right into the IDE, so we can run an application either on a physical device or an emulator and set breakpoints, examine variables, and so forth. Here's the interface builder, a screenshot of the interface builder tool. So here you can see what we call a storyboard, and instead of seeing code, you actually see screen designs as well as the segues or the connections between these various screens, so we can actually design out the whole flow of the application. In this case, this is a storyboard. So in terms of creating user interfaces, we have a couple of options when we write an iOS application. We can use nib files to instantiate the UI, and these are going to take one of two forms. Either it's going to be a .storyboard, and a storyboard contains multiple screens as well as the segues between them. So this is something Apple has added to Xcode more recently, the ability to put multiple screen designs as well as the flow among them into a single file. These are called storyboards. A .xib, we pronounce these nibs as well, but these were the traditional way that we created screens in Interface Builder. And a nib here, the file with an xib extension contains a single screen at a time, and then we'll programmatically control the flow from screen to screen. Now another option is we can avoid using interface altogether, and we can programmatically create the user interface. In other words, the view hierarchy can be created completely in code if we wish. Now there are certain situations where we might want to do that. So for writing a video game, for example, most of the time we're using 3D graphics programming, and the interfaces are quite custom in a video game. So it's likely for writing a video game we're not using the interface builder, although we may for a scoreboard or something that uses common controls or stock Apple controls. But more than likely, if we're doing something like that, we do it directly. Or if we simply have a very custom iOS app that doesn't use any of the stock user interface controls from Apple's UI kit, but we're simply writing all of our own from scratch. In that case, we might want to use write it in code. So which of these approaches are best? Well, it really depends. So storyboards are certainly the easiest to work with, but they have a problem in that if we've got multiple developers working on the same mobile app, and more than one developer tries to edit that storyboard at the same time, sometimes it's very difficult to merge those changes, and often we find ourselves discarding one of the changes and reapplying them manually. So many shops will use just plain old nibs, a single screen per file, and avoid using storyboards for that reason. Now, it is possible. There's ways with a little bit of discipline, self-discipline, and being practical. For example, we could have a physical token if all the developers are co-located, and the only way you can update the storyboard is if you have that physical token in your possession. So there are some ways we could avoid the problems and still use a storyboard. And as I've already mentioned, if you've got a highly custom user interface, you might avoid using nibs altogether and just develop your view hierarchy directly in code. So here's a screenshot of the debugger. You can see our source code is showing, as well as the debugger screen on the bottom. And over in the left nav, you can see our debug navigator. It shows us the CPU utilization as well as memory. It also shows us the stack on the thread that we're currently trapped on, and so forth. If we look at the debugger itself, there's a couple of subviews within the debugger, the integrated debugger. So on the left side, you can see a nice structured view where we can explore the current scope, so all the variables that are currently in scope. And then over on the right, we have a GDB style console where we can print out the values of objects, set additional breakpoints, and so forth. And there's also a toolbar at the top that has all of these commands. So if you're proficient in GDB, you might find yourself interacting mostly in that console over on the right side there. There are links on these screens that you can click on after you've downloaded the slides and explore these features in more depth. iOS, or Xcode I should say, contains a iOS emulator for us, and these allow us to execute the application we're developing right on our Mac computer. And so this allows us to develop an application without physically having a phone or an iPod Touch or an iPad in our possession. Now keep in mind there are some device features that today you cannot emulate with these emulators. For example, if you're using the camera in your application in any way, you're going to need to test that feature on a physical device. The same thing holds true if you're using Bluetooth for connectivity, or you're using the accelerometer or some other sensor on the device. And a good rule of thumb is that you should always test on a real device prior to submitting that app to the App Store. It's always a good idea to test on the physical device and not just rely on the testing that you've done on the emulator. So on the iPhone, or on the iOS platform, there are two main form factors. We have the smartphone, or the iPhone, iPod Touch, and then we have the iPad, the tablet. Now when we're creating an application in Xcode, one of the things it's going to ask us is which of these form factors do we want to support, or do we want to support them both with the same binary? And that's what the universal option is. We can write a single binary and submit it to the App Store, and it will run and take advantage of the larger screen if it's on an iPad and still function and look great on an iPhone as well. So that is a universal app, single binary, but it supports both the iPhone as well as the iPad. Now, our goal is to get as much code reuse as we can over these two platforms, and yet the view hierarchies will likely be different on an iPhone versus a tablet. But the universal is a nice way to get a single app out in the store that runs on both form factors. Now I just want to talk very briefly about the software architecture here in iOS, and we'll get into this much more deeply as we go. But first of all, a design pattern, as many of you are probably aware, is simply a solution to a problem in a context. Apple has crafted the iOS frameworks in terms of some well-known design patterns, and as we dig into the details of iOS, we'll start to see these patterns come up over and over. And there's a link there to an article that you can read about the Cocoa design patterns, but the one in particular that we're going to be using a lot is Model View Controller. And this is a very common, most modern graphical user interfaces use this particular design pattern or something very similar to it. We have three components in a Model View Controller pattern. We have the views, which are the things that the people see on the screen, and we have a model, which represents the data that our application produces as well as consumes. Now it's important that we keep the model in the view separate from each other, and so we have a third component, a controller, that manages the views and the model. And so if we were to, example, interact with a view, push a button or scroll something on the view, a user action event is sent to the controller, and at that point the controller can decide whether or not it's going to update the model. If the model does change, so if data changes in the application, the controller will be notified of that change, and then it can decide whether or not that update to the model needs to be reflected in the current view hierarchy. So this is the basic pattern that all iOS applications are crafted with, and we'll be looking at this in a lot more detail as we go forward. So the first thing we want to do is let's just pull up Xcode and let's just write our first simple application in Xcode, and we won't make it real fancy. It'll be somewhat of a hello world, and just get a feeling for how the tool works and how easy it is to get something up and running on the device. So when I first start Xcode on my desktop, I'm going to see this dialog window, and it asks me what type of project do I want to create. For this demo, I'm just going to go and create a new Xcode project. And I have two different types of projects I can create, and since I'm doing iOS development, I'm going to select out of this top category, and in particular I want to select an application. Now that I've selected that, you can see there are a bunch of different types of applications that I can create. So these are kind of like scaffolding. The IDE will just create an empty project, but a fully functional project, but with blank screens, and I simply need to flesh out the details. So let's just take the master detail application, and the next thing it does is it asks me for a name for the project, and I will simply call this my first iOS app demo, and there's my name. And this information here, the organization name, simply shows up in the copyright header in the generated code. And then the other thing I need to do is select a organization identifier. And this is a namespace. This is very much like in Java, for example, when you name your packages and so forth. It's what helps us keep our app from being confused with other apps that might have the same name in the App Store. So this is typically your company or your university domain in reverse order. And the bundle is actually going to take the name and append it to that package. And so the bundle identifier is your app's unique identifier once it's deployed in the App Store. Under language, we have a couple of different choices. We could go with Objective-C, or we could go with Swift. And I'm going to select Swift on this particular option. And then in terms of devices, remember we talked about the two different types of devices, either iPhone, iPad, or Universal, which I'll pick here, which says support both iPad and iPhone. So having filled that out, I'll leave this use core data unchecked because I don't need that. The next thing it's going to do is ask me, where do you want the code? I'll just take the default directory here, and notice there's a little checkbox down here in the bottom for source code control, and I would just leave that. I would check it if it's not, and leave that checked, because this basically puts your project into a Git repository. If you don't know Git, I'm not going to talk about it in this course. I'm just going to assume people know it. But if you don't know it, I would encourage you to go out and learn how to use Git. It's a very powerful tool, and even if you're developing as a single developer on your project and there's not multiple people involved, Git is still a great way to keep track of your changes over time and to be able to roll back and reproduce earlier configurations of your builds and so forth. So I'd highly recommend you use that. I'm just going to create them, and it will create the application for me. And now I'm in Xcode. You'll notice that it's got that nav explorer over on the right. And so you can see that there's several Swift files here. There's an app delegate, master view controller, and a detail view controller. And we're not going to get into the details of those yet. We'll look at that. I just wanted to create an app and run it for you, and just point out a few things for you. There's also a storyboard, and let's just click on that. And when I click on the storyboard, you can see that there's actually a couple of different views in this storyboard. And when we start to run this, hopefully it'll make sense, but there's a split view controller, and then there's a table view and a detail view. And we'll take a look at that when we run it and explain it. Over here on the right is our attribute editor. So depending what I've got selected over here in my table view, I can actually edit different properties of these different components, whatever I've selected. Down here's my library. If I wanted to drag more things out on the screen, I could do that. And there are many other things here we'll talk about and we'll get into. But for now, let me just go ahead and run this application. To do that, I'm going to look up here in the upper left, and you'll see that I'm targeting the iPhone 6. That is an emulator. If I had an actual device hooked up, you'd see the name of the device right there. But we'll just go with the iPhone 6. And to run the application, I simply hit this little play button up here, and this will start the emulator up on my desktop. And there it is. It's kind of small. It's scaled down. So if I go to the window screen here, I can scale this up a little bit. We'll go to 75%. Oh, maybe we could even do more. Let's go 100%. Yes. Okay. So there's 100%. So this is a master detail style application, and it's kind of hooked up with some dummy functionality. So if I hit this plus key, it adds entries to this table view, and I can just touch and drag here to scroll up and down, and I can also click edit, and I can delete entries using the standard deletion functionality. If I select a row, it actually does a segue and goes off to a detail screen. Now if you think about it, this is a very common style of application on an iPhone. So whether you're using a Twitter client or a Facebook client, you have a whole stream of tweets or posts, and when I select a particular one of them, it drills down in and shows the detail. So if we were to go out here and look at the code, you'll see controller code here that basically integrates with that view that we were just looking at, and gives us all that standard behavior. If we were actually writing a real application here, we would go into this code and we would extend and customize it to display exactly what we want to do and to support what interactions we would like to do. So that's just a really quick kind of tire-kicking demo of Xcode, and we'll be spending a lot of time in Xcode. But before we start digging more deeply into the iOS framework, we need to take a look at the Swift programming language. So the topic of our next lecture is the Swift programming language.